5, 4, 3, 2.
In May 2018, NASA launched the next mission to Mars.
Liftoff.
An Atlas V rocket took off from the Vandenberg Air Force Base in California, the very first interplanetary launch from the West Coast. Aboard the rocket are 2 CubeSats, which are the first of their kind for a Mars mission, and a robotic lander. The goal? Touch down successfully and investigate the deep interior of Mars. Over the decades, there have been a series of critical missions to the Red Planet. Flybys that took our first snapshots of Mars, landers that characterized its atmosphere, orbiters that studied its geology and climate, and rovers that are investigating the presence of liquid water. The next phase is the interior exploration using seismic investigations, geodesy, and heat transport, or InSight.
Everybody has seen pictures of what the inside of the Earth looks like. You see the core and the inner core, and we make pictures like that for Mars, but it's just guessing. This is the first time we're actually going to know what the inside of Mars looks like.
We're using 3 processes: seismometer, heat flow, and precision tracking.
The lander is outfitted with a suite of sophisticated instruments, each with their own research goal and acronym.
The seismic instrument is called SEIS, S-E-I-S. That's Seismic Experiment for Interior Structure. That's going to be listening for Mars quakes.
This seismometer is very, very sensitive. If a butterfly lands on it and flaps its wing, it's going to detect it.
On Earth, most of the earthquakes we see are driven by plate tectonics. We don't expect to see that on Mars. The seismology lets us look at how active the surface of the planet is. We can look at the way the waves vibrate, which direction they vibrate, and we can use that to determine which direction the quake came from.
Next up is the Heat Flow and Physical Properties Probe, or HP3.
One of the biggest things that we need to understand when we look at how planets evolve is understanding what is happening with heat. Most planets, you can think of them as heat engines. Everything they do involves how heat starts out inside the planet and gets out.
We have what we call the heat probe that we're going to dig deep into Mars.
That lets us know how Mars is evolving, how it is changing over time, how it has held on to the heat we can predict it had early on in its history, and how much heat it has now.
There's also the Rotation and Interior Structure Experiment, or RISE, a precision radio science instrument that'll track the position of the lander and help determine what Mars's core is made of. All of these instruments will be placed on the planet with a 2.4 meter long robotic arm that has
4 degrees of freedom, a grapple, a camera, and a second camera mounted underneath the lander. This is the first time we're going to do precision placement on Mars, where we take an instrument and install it on Mars, and it's going to be its final resting place. And we're doing all these things hundreds of million miles away, blindfolded literally.
Right now, the InSight spacecraft is on a 6-month cruise to Mars, tracked by NASA's Deep Space Network. It's tucked away inside an aerodynamic shell and protective heat shield. Once it reaches the point of descent, NASA engineers will prepare for the difficult, nail-biting endeavor of landing InSight on Mars, otherwise known as 7 minutes of terror.
InSight is not going to use the sky crane technology to land on Mars. It's going to have a parachute to slow it down and to land with this retro rocket.
It'll touch down in the Elysium Planitia, about 373 miles from where Curiosity hangs out.
It had to be close to the equator. That's because this mission is solar powered, and it needs to be powered all the time so that the seismometer can always be running.
We still have no idea how our planet's formed, and by taking the vital signs of Mars, the InSight mission will help us begin to understand that.
This is pure exploration in a lot of ways. We don't know these answers, we have estimations, but it's going to surprise us.
Current altitude is 13 miles, downrange distance 7 miles, current velocity 1,965 miles per hour.
Thanks for watching, and make sure to follow Focal Point so you can catch the latest innovations and scientific breakthroughs. Don't forget to share and let us know what you think in the comments below.